Using elementary transformations, find the inverse of each of the following if exists in the following exercises. Now, this question 4 already we have done in the example, done as an example when I was teaching you that how to find the inverse of a matrix of second order using elementary row transformation. So this has been done. Now out of this 2, 3 and 4, I am leaving question 1 for you to try, and I'll try question 2 and 3 one by one. So let me take question 2. Let me take question 2 first of all, that given is a matrix A, 2, 1, 1, 1, and we have to find A inverse using elementary row transformation. Now what is the procedure? We start it like this, that A equal to IA. We write the value of A, 2, 1, 1, 1, I, this being of second order, 1, 0, 0, 1, the identity matrix, and A will continue to write as such. Now what are the steps? The steps are that first of all, this number at the corner, that is A11 if you call it, it should be 1. This should be equal to 1. Now there are two ways, either I multiplied R1 by half, or you interchange. If you interchange R1 and R2, automatically in R2 the first element being 1, it will come at the required place. So interchange R1 and R2. You get 1, 1, 2, 1, and do the same on the right hand side. You get 0, 1 and 1, 0 times A. Now what is the second step? You want to reduce this 2 to 0. And it can easily be done if you replace R2 by R2 minus 2 times R1. So by keeping the first row, that is the element 1, 1 as such. Now 2 minus 2 times 1, that is 2 minus 2 is 0, and 1 minus 2 will make it minus 1. Similarly, on the right hand side, the first row 0, 1 will remain the same, and second row 1 minus 2 times 0 will keep it 1 only, but 0 minus 2 will make it minus 2 and A as such. Now our next step is to make, the A22 1, and that can easily be done if you replace R2 by negative 1 times R2. That means the elements of R2 you multiply by negative 1, keeping the first row same 1, 1, multiplying by negative 1, it is 0, negative, negative, it becomes positive 1, positive 1. On the right side doing the same, keeping R1 the same, you get 0, 1, and the second row will change the sign, negative 1 to A. Now what is the next step? By the way, this is already 1. Now we want to make this 1, that is A12 as 0. And for that you apply R1 to be replaced by R1 minus R2. So you get 1 minus 0 will remain 1. 1 minus 1 will make it 0. Second row, the 0, 1 as such. Apply the same on the right hand side. So 0 minus minus will make it plus. So it will be 1. And 1 minus 2 will make it minus 1. And the second row minus 1, 2 as such. So yes, on the left side now we get I. On the right side if I call it BA. So obviously A inverses B, which we calculated as 1 minus 1 minus 1, 2. So finally I say that in the present case the value of A inverse is 1 minus 1 minus 1, 2. That is the required answer for second question. And now let me take the third question also. Take question 3. Find A inverse, where in question 3 A is again a matrix of order 2 by 2 defined as 1, 3, 2, 7. It is rather a simple question because A11 is already 1. See, how do you proceed? You write I equal to, A equal to, we write A equal to IA. The value of A is given to be, the value of A is 1327. On the other side I, the identity matrix of second order is 1001 into 8. Now this number A11 is already 1. Now we have to apply now the second step to reduce this 2 to 0. So obviously you change second row by R2 minus 2 times R1, keeping R1 1 3 as such, and here you get 2 minus 2 times 1, that is 0, and 3 minus 7 minus 2 times 3 is 6, so we'll make it 1. Similarly on the right side, keep the first row as such, and in the second row when you apply R2, that is 0 minus 2 times 1, will make it minus 2, and 1 minus 2 times 0 will not make any difference, we'll keep it 1 times A. Now we have got 1 0 1. Now the only thing that this 3 has to be changed to 0, so you apply R1 to be replaced by R1 minus 3 times R2, so that the 3 becomes 0. So you get 1 minus 3 times 0 will not make a difference, 3 minus 3 times 1 will make it 0, so you have got the required left hand side 1001. Applying the same on the right hand side, you see 1 minus 3 times 2, 6, minus plus 6, so you get 7, and 0 minus 3 will make it minus 3, and minus 2 1 as such into A. So now it is in the desired form that I equal to BA, so A inverse is B, which happens to be 7 minus 3 minus 2 1, and hence the required value of A inverse, we have got the A inverse, we have already got as 7 minus 3 minus 2 1, that is the value of A inverse. And as I have already discussed with you, that question 4 has been done in the solid exam.